Hello, everybody.
Hello.
Get this up. And we do this. And we play from current slide. Okay, you all see the menu?
Yeah.
Okay.
Yep.
So we'll just follow up some tidbits from the Ukraine, and I invite all of you to contribute if you got something. And then I'm just going to remind you about the June 1st special talk. Then we're going to possibly do a little bit of show and tell, but I think I'm going to postpone that and do the history of California. We've been waiting long enough. Okay, the Ukraine, Mariupol, that steel plant that finally surrendered. But you remember I introduced you to the Azov battalion. They're very active along the Black Sea. They were implicated in 2014 in a couple of really bad battles where there was atrocities on both sides. And then after they surrendered and finally gave up that steel plant, there was something that hit the web trying to link them because they had far right wing influences. There was an effort to link them to the Buffalo shooter, but that's been debunked by Newsweek. They fact checked that. But where the heck did that come from? That came from Putin, for sure. You'll remember that his justification to go into the Ukraine was to get Nazis. And there's stuff in the Azov background, unfortunately, that reinforces that. I told you who their founder was earlier on. I told you what their symbols amounted to. And that one with the black sun, that has been totally debunked. But you'll remember that the US government did its own investigations after the Azov battalion was given contracts to serve in the Ukrainian National Guard. And on the basis of that, Congress blocked military aid because of their white supremacist background. That was led by John Conyers, who commented about the repulsive neo-Nazi Azov battalion. So they're talking now about a show trial in Russia of these guys that they captured. And so now maybe we understand why they just didn't destroy. They wanted to capture the Azov brigade for propaganda purposes, is my theory. So watch the headlines. Putin may use these guys as proof. And the Pentagon, though, resisted Congress, and those guys were under contract and part of the Ukrainian National Guard. A second thing that popped up is this Ukrainian resistance that is unified and spread out over large distances. And how are they able to do that? And somebody said it's a Cossack thing, the ability of local militias to organize and come together. That's what Ukrainians do. This is from an article in The Economist. So that took me back to our first encounter with the Cossacks back in 1648 when we were doing the history of the Ukraine and how the Cossacks rebelled against Poland and eventually went into an alliance of convenience with Moscow. And we know from unfortunately, the history of pogroms, it was the Cossacks that were part of these anti-Semitic pogroms. But the Cossacks went into a formal union, and this 1654 is a big date. The Russians and the Tsars in particular made a big point of that date, that's when the Ukraine decided to go with Russia in the East instead of with Europe in the West. But they took up the Orthodox religion lightly, and at one point, in alliance with Moscow, they controlled a large amount of territory, but very informally, and never Galicia in Western Ukraine. We talked about the Battle of Poltava and Peter the Great, and how the Cossacks switched sides. And even Putin admits that they were fickle allies. So today, the people who in the Ukraine who are anti-Russian are derogatorily referred to as Masochists. But on the Ukraine side, they've rehabilitated him, and he's become kind of a Ukrainian hero. I think this picture says a lot about the spirit of the Cossacks and who they were, and rough and ready militias as they're negotiating with the Sultan, writing him a letter. This was pointed out by one of our members. The lyrics of the Ukrainian national anthem include the word Cossack, prove that we are brothers of Cossack kin. So this Cossack spirit of independence is still going on. Poland had clawed back a lot of the land from the Cossacks and reduced their influence by 1751, but then the three emperors divided Poland. And you'll remember Catherine the Great sent German peasants to teach the Cossacks how to farm. So the unifying myth, and this is from the Economist article, was that the Cossacks were free men who took advantage of the wild fields in the lower river valleys emptying into the Black Sea. There was a lot of wetlands, and they were hard to farm and hard to settle. So that's what's meant by the wild fields. And they were always self-organized, informal militias. They never were a standing army. They were romanticized by Gogol, who says, in the case of war and general uprising, it just required a week for every man to appear on horseback fully armed. And in 2 weeks, they were a fighting force, very organized. And this spirit was recreated by an anarchist Cossack in the 1920s who fought all kinds of state control, Polish or Russian. That's the end of what I have to say about the Ukraine. Anybody else have any comments, anything they've discovered that's related to what we've talked about before?
I'd like to ask a question.
Sure.
Was Zelensky not too fond of the Azov battalion?
I don't know specifically about Zelensky. I know that the military prevailed on him and felt that they were a valuable asset, as they had demonstrated in 2014, particularly in Odessa, although in Odessa, that was where one of the biggest atrocities took place. You'll recall pro-Russians were burned alive in a building, and who knows if it was who started what and whether it was response into an equally great atrocity. I don't know that. And I don't know that specifically about Zelensky, but for sure, being Jewish and knowing the history of Cossack role that was played in pogroms, he would be cautious.
Thank you.
Okay. Any other comments or questions?
Oh, I was just wondering, my teacher said some Russian quit his job and said Putin was wrong in this war. And I looked all over my paper and I can't find it. Do you know, they said some high level official yesterday.
Yeah, he resigned yesterday.
Who was it?
I don't know what his name was. I'd never heard of him before. I'll email you, but I saw it in the New York Times. It was mentioned.
This is Carol. I think he was the UN representative, the guy who resigned.
Oh, okay.
And then before that, there was a high level Russian, I think he was he in the military maybe, who denounced it. And then he rescinded his comments like yesterday.
Oh, he did?
Oh, he did.
Yeah, he sort of he didn't completely rescind them, but he basically backed out of what he was saying, so.
Yeah, the guy that made the comments yesterday and resigned, he did not, I couldn't tell if he was still in Russia or if he was outside of Russia. He said he would have come out and said something sooner but he had things to settle. And I thought, well, geez, maybe he was trying to get out,
Well, I'm sure he was out before he did, but so he's the UN representative. So is he at the UN, or, I mean, there's a big Davos meeting, right? So
Yeah.
is he there?
My guess
is he's like, he better hire a food taster because
Really?
All this is fascinating, and as the news unwinds, but we don't do much history until it's aged 20 years. So no, this is fascinating, and I'm delighted to spend a few minutes on this. But this topic that's coming up on June 1st, in contrast to what's been going on in the last few days, looked at the East-West dichotomy that went back to the lower Paleolithic times. And so this is, I think, is going to be fascinating. Ramsey said as much, and he's sorry to miss it. So I hope our core will be there, and other people as well. Okay, we did how California got its name last week, so we'll skip over that. If any of our newcomers want to visit that, it's the end of last week's session. And I'm going to introduce a few themes as we do California. That California, in many ways, is the newest, the last, the most tumultuous, and the most diverse. And I'll give you just examples of each. It's new because it's new land created by scraping off of subduction. We'll get into that. It's a newish state. It was the 31st state. It was the last part of the world that remained undiscovered by Europeans. particularly Northern California, particularly the Bay Area. The Spanish and then the Mexicans pushed into San Diego, but nobody knew about the Bay Area really until quite late, and I'll show you that in detail. Sir Francis Drake missed it repeatedly because the Golden Gate was either enshrouded in fog or it was backed up by Angel Island, and he couldn't tell. You couldn't tell from a distance that you could get in there. And Martinez, where I've spent the last 50 years working, was really a backwater of a backwater of a backwater until gold. And then tumultuous, why? Because of the earthquakes, and the economy is constantly being revolutionized. First gold, and then big time irrigation and agricultural development, and then Silicon Valley. And that's leaving out things like the arts and Hollywood. A lot of interesting developments in the economy. And then finally, diverse. It's not just the people that we're accustomed to, but we'll find out it's the geography of the place. All the rocks are diverse. So let's first look at the map that Drake might have had as he was sailing up. This was terra incognito in Latin. It's hard to see on the map. We saw this in a museum in Mexico, and I just had to take a picture of the missing California. And the Spanish kept missing it. They'd go from Acapulco following the trade winds to Manila. And then they'd come back following the trade winds from Manila to back to Acapulco, going along the coast. And that was it. These ships went with silver at least twice a year. And they bought back whatever they could buy in Manila from the Chinese, basically. But they never saw the Golden Gate, and as I mentioned, they'd sail along here, and Angel Island was behind the Golden Gate, or if it wasn't in fog. Then Drake, he took off and went all the way around. We're talking the late 1500s. And he went by the Golden Gate, never saw it. This was the boat that that's been reconstructed. That's in the harbor in London. That I was very excited that we could visit. But Drake finally landed in Drake's Bay. Point Reyes in 1595, but never appreciated the Golden Gate. And here's a depiction of that meeting between a European, the first meeting between a European and Northern Californians. Okay. So it wasn't until 1769 that the Spanish realized there was such a thing. And they didn't discover it from the sea, they discovered it from land. They were running out of food, and they sent a party to go up to Point Reyes, because they thought that the Spanish knew about Point Reyes, and they thought maybe there was a supply ship waiting there. And as they're trying to go overland for the first time to Point Reyes, they encounter this huge backwater. our wonderful bay. And you can visit the spot. It's Sweeney Ridge, up in the where the Spanish first had the vantage point to see the bay. So Sweeney Ridge, Google Sweeney Ridge, and the trailhead is there. And where we've been in Contra Costa is a backwater of a backwater. So if the Bay Area was a backwater that went undiscovered, Contra Costa means, which means opposite shore, was also further, even further removed. And then once they settled over in Berkeley and Oakland, and what are now Berkeley and Oakland, they had to get food. And so settling a rancho in the local area was very important. And so where the convenient place is to have a ferry boat that goes around the Carquinez Straits and accesses the Alhambra Valley, which was Martinez. And that this is the reason Martinez is the county seat of Contra Costa County. It's not in its populated area of Richmond, but this was, if you will, the breadbasket for the first settlements on the opposite shore. So it's a backwater of a backwater of a backwater, and that's where I've worked for 50 years. And this shows what might have been the first rancho. And I dare say some of you have passed it in your car many times. If you've gone to downtown Martinez, you will have noted under Highway 4 that there are 6 panels that depict California history. And you will be seeing all 6 in the course of our visit to the Californian history. All right, so that's the modern introduction. But now we're going to go back 230 million years ago to when the first mammals roamed the planet. And the reason we're doing this is if you look at how the continents were shaped, they were all together in one landmass called Pangaea. And if this is the part of Pangaea that would become North America, and you can probably appreciate that California is missing. There is no California. It doesn't exist in this time frame. In this time frame, mammals developed like 220 million years ago, and they're spread across different land masses, different continents. So you get some similarities, but some unique appearances. For instance, some species are only available in a couple of continents. Now, in 175 million years ago, this huge landmass starts to break up. And so we have a reason to look at geological time. I'm going to try to make this as simple as I can, but California, the formation of California really forces us to expand our time frame. You can forget the bars on 2 bars on the right-hand side. So we're only going to even consider the more recent, if you will, geological times scale. Now, in these two were important because there were three mass extinctions in these oldest time bars, and they were from volcanoes and comets and extreme temperature changes and rising and falling seas, wiping out sea species. The time scale, by the way, is not the scale. It's there's some liberty taken in putting down the years, but we're trying to keep this as simple as possible. So it gets interesting here with the first mammals, as I said, 230 million years ago. But there's the fourth extinction that happens right here, 200 million years ago. And this gets us into the Jurassic. So the Jurassic gets to mop up from the fourth extinction. There's a clean slate. And 79% of the species had disappeared. So there's a vacuum. And it's in this time frame in the Jurassic that the Pangea, the mass continent, starts to break up around 175 million years ago. About the same time, you get the first birds. They're later than the mammals, and then you move into the Cretaceous, and you get your first flowering plants. But lo and behold, that's when that big comet strikes in the Yucatan 65 million years ago. And 50% of species are wiped out in that fifth extinction. And so now we move over to our most recent bar. And this, we're going to focus first on the lower 2/3 of it and dispense with it pretty quick. 66 million years to 23 million years ago is the Paleogenic era. And this is when the first primates appear, 55 million years ago. And then you move on up, and you get the first great apes, and then you get something called the Neogene Barstow Formation in California 15 million years ago. And this represents a geological period that they discovered and could understand better when they discovered layering in Barstow, California, of all things. And then around that same time period, you get the first great apes. And then our final time period that we're going to consider, and now it's very small in relative terms, but this is what we're most interested in, the Pleistocene. And that's when Homo sapiens are beginning to take shape, not quite there yet. And that goes from 2.6 million years ago to 10,000 years ago. And we recognize the 10,000 years as being what's called the agricultural revolution, where humans use their brains for farming and plants. So some of these dates are, as we look at the development of California, it's going to be handy to have these dates in mind. I know that was a lot of detail. Any questions? So here's Pangea again, just as it's breaking up. Now you can see the foreshortened West Coast. No California, nothing like it. Stunning.
Excuse me, Johnny, what causes it to break up?
It's sitting on molten fire, tectonic plates. And they after a few billion years, they get restless and detached, and there's plenty of energy to move them around. I think an interesting question is, why didn't they move sooner? I don't know. I don't know. All right, so let's actually get to California now. Here we go. The Farallon plate. So we're all familiar with the word Farallon from the Farallon Islands. But before there's a Pacific plate, there's a Farallon plate. And it's sitting between the continental North America continent and the Pacific plate. It's sitting between. And the Pacific plate is kind of moving towards the continental plate and pushing the Farallon plate in front of it. But it's what's scraped off the Farallon plate that creates California. What's scraped off the seafloor of the Farallon water plate. This is all seabed that's scraped off first into the Great Valley, and then something called the Franciscan assemblage, as you might guess, might have something to do with San Francisco. And the North American plate continues underneath what's scraped off, and it's got actually a sharp point to it, almost like a scraper, right? This leading wedge of the scraper is going to pop out later on above the water, and that's going to be interesting. You'll see. But that's the North American plate. Now, the descending Farallon plate, you can look at this map, and unfortunately, the colors are not consistent between the two maps. But you can see the red is what results from the Sierra Nevada volcanoes, and the Great Valley in yellow and green matches the green color here, and then the blue and pink are going to be the coastal ranges, and that's interesting to us because we live right next to it, and it's a big part of our lives, and we go through the Caldecott Tunnel because of them. Here are the coastal ranges as shown on this map, a little more distinct than those pink and blue areas, but it's the leading wedge of the continental plate that's nosing out here to push up. If not comprising the coastal range, at least it's pushing it up. And so you have these different regions that are very distinct to us. We've already talked about all of these regions, and they're each created by an aspect of subduction.
Can I ask you a question?
Yeah.
So the Pangaea map shows that California didn't exist. Now, if you go to the map before this one, it looks like the Mojave Desert and the basin basin and range. It looks like it was Precambrian. Was that what it was? Can you go back to the slide before?
Can you hold the question? Because I think I'm going to be addressing it with the coming slides.
Okay. Okay.
Yeah. So this is the description of John Rawls, who wrote the book I'm going to be talking about in just a second. And he talks about how the western edge of the continental plate nosed out along the ocean floor, and that sedimentary rocks and ocean crust material were churned up in great confusion and forming our coastal range. So our coastal range is kind of a mishmash of many different forces. John Steinbeck talked about the coastal ranges, and I'll be able to. I'll save this and talk about it a little bit later, because it's well, this is later. This is where Steinbeck grew up in Salinas, and this is the Salinas Valley, and he talked about this mountain range to the east, very lyrically and poetically, as being bright and sunny in the direction of hope and goodness. But these mountain ranges on the west side were more foreboding, even evil. And so let's see what he actually says now that we've seen the map. He saw the two mountain ranges as being a metaphor for the struggle between good and evil, that the East was inviting, light and gay and lovely, and the West was dark and brooding, the Santa Lucia Mountains. So two different, I thought I wanted to throw in a little bit of lyricism with this heavy dose of geology. But this is, the Salinas Valley is notable as an exception. It's the biggest consequential break in the coast. Sure, you've got the Klamath River, and we've been up there. It's the Yurok Indian Reservation goes for a half mile on each side of the Klamath, but in terms of the importance of, in particular, the economy of California, the Salinas Valley is the one break in the coastal ranges of central California, and it's kind of linked to the Great Valley, and it was so important to John Steinbeck. So I've quoted Rawls, so I'm just going to repeat who he is. He wrote this book, An Interpretive History of California. I recommend it. This is the 10th edition, the latest. It's already 10 years old, but the history we're going to look at hasn't changed much in the last 10 years. And so it's that book. Rawls was a teacher at DVC, and he was so popular for a while, he did a radio show, and Walt Disney hired him to help them build their California world, the part of Disneyland that looks at California history. And I like the way his book is organized. I set out the table of contents before. If you want me to send it out again, I will. the 10th is more expensive. It's the 8th edition has the same table of contents. So if you want to get the book, and there's a difference in price between the 10th and the 8th that I don't quite understand, but it's the same table of contents if you want to get it. All right, so back we go to subduction. The Farallon plate has dived down, and its leading edge, the friction between the two plates is huge, and it causes this unbelievable amount of heat that the heat itself dissolves rocks, and the end result when those rocks come up to the surface is a granite. When it cools, it comes up to the surface and it's granite. But the heat itself does interesting things with minerals. And of course, the one mineral out of probably 9 or 10 that's really mixed in with this granite is gold. Seams of gold go up. And so we'll come back to places that you've been to where there's a lot of granite around that are very beautiful. But let's look for now at the fate of the Farallon plate. The Farallon plate is here, and this is this red zigzag line is the western border of the Farallon plate. Now remember, it's being pushed. And so I'm just going to show you that the Pacific plate is pushing it, not directly, and this is important for the history of earthquakes, not directly. The Pacific plate is actually moving more to the north, but it's got a glancing pressure on the Farallon Islands, that the resolution of which is to continue the subduction of the Farallon plate, and a shearing force, if you will. And it keeps pushing, and it keeps pushing. And something happens, the names have changed, and this is going to be the name of Juan de Fuca. So what's Juan de Fuca? So 30 million years ago, the Pacific plate, its sharp edge, splinters the Farallon plate. It just breaks it in half. And the northern part of it is Juan de Fuca. And I've been encountering the Juan de Fuca plate just incidentally, and always wondering what happened. Well, this is the birth of the Juan de Fuca plate. It did not exist until the Pacific plate splintered it 20 million years ago. And then the Pacific plate keeps pushing until the Farallon plate is completely underneath. But remember, the Pacific plate isn't going to follow it underneath. Its resolution is to head north, not to continue east after the Farallon plate. But the Juan de Fuca plate is still there, and it is still, to this day, subducting, and it's still subducting. The Pacific plate is continuing to go to the northwest, and Los Angeles sits on the edge of it. San Francisco is on the North American plate, and someday Chicago, Los Angeles, and San Francisco will be twin cities. and that'll be interesting. So off we go. Who was Juan de Fuca? So he was not Spanish, he was Greek, and thus the kind of odd name, Juan de Fuca. This is his, Ionis Phocas is his Greek name. And, but as in those days, it was a very international enterprise. And we know Christopher Columbus was Italian. And now you've got a Greek that the Spanish hire to explore the west coast of this new world. And his claim to fame was that he found an entrance to the Northwest Passage that would dump out in the Atlantic Ocean. He did not find that, but he thought he had. And this was his map. What he had found is the Strait of Juan de Fuca, which is the body of water just south of Victoria and the Vancouver Island. So the name of the big city is Victoria, but it's Vancouver Island. The city of Vancouver is over here. So you got to keep all that straight. But this is what Juan de Fuca found. He mucked around here. He wasn't sure exactly. He thought he was in the Northwest Passage. And he came out and wanted some credit. He didn't get it. And he retired. And then there was an Englishman named Locke, and the Spanish history spelled Locke this way, who tried to entice Juan de Fuca out of retirement to serve with Spain's arch enemy, Queen Elizabeth. Nothing came of those proposals, but they kicked up so much controversy in the fog of war. Over time, there were people, scholars that thought Juan de Fuca was never existed, because what's a person working for Spain would switch sides and join England. But the latest history is that he was not fictional, that he was real. So to have an important plate named after him makes sense. So let's see what the Juan de Fuca plate is doing. It's you remember, it's the residual of the Farallon plate. And it gets mushed in. The rest of the Farallon plate gets pushed into a straight line. So now the Farallons down here disappeared under the earth and are absorbed into a deeper layer of the North American continent, and therefore exist no more as a terrestrial entity. But the border continues to exist, and the Pacific plate continues to move into the Northwest. And so what we wind up with is this small little bitty plate, the Juan de Fuca plate. I don't know if there's another plate that's smaller than Juan de Fuca, but there it is. The Pacific plate is gigantic, gigantic. And this, of course, defines the Ring of Fire. It's a huge, it causes earthquakes here because it's moving lateral, but wherever it moves, it can cause volcanoes in the Ring of Fire. So this is the Pacific plate. This is what's left of Juan de Fuca. The rest of this map is interesting, and you can study it at length if you watch the video. Rawls uses this little history as an interesting metaphor. he points out that the material that formed California came from the entire Pacific basin. And that Pacific plate stretches over half the surface of the earth. And so he finds what's embedded in our physical world to be a metaphor for the diverse culture and ethnic state that we have. An interesting point, and I like people that take, like Steinbeck, who take kind of dry science and find metaphors. So what is the effect of the continued subduction of the Juan de Fuca plate? Well, you're getting those same really hot forces that created the granite that pushed up the Sierras, but up north, where Juan de Fuca is moving and subducting, you still have active volcanoes, as we well know from Mount St. Helens. And that we also know from Lassen. Lassen is part of the Juan de Fuca plate, even though it's in Northern California, and it blew 100 years ago. We went up to Lassen, and they have photographs and pictures of what happened just 100 years ago in our state at Mount Lassen. Shasta itself is still listed as a potential volcano, as the ranger told us when we took our grandkids up there. So Juan de Fuca causing problems as it continues to subduct in the very most northern part of California, but certainly in Oregon and Washington and lower Canada.
The San Andreas Fault, the easternmost part of the North, the Pacific Plate.
It is indeed. That's exactly that point is coming, and you anticipated it well. And the San Andreas Fault shows the eastern boundary of the Pacific Plate as it moves north. So Baja is moving north. Yeah.
No wonder there's such a giant movement if the San Andreas Fault moves, because it's the whole damn Pacific Plate pushing in.
You got it. You got it. So here's just another map showing the same thing. Here's subduction. Here's the heat produced by subduction. And here are all the hot spots and the Cascade volcanic arc. Not all of them are major volcanoes, but they're potential. And so, and here are the two we know. Lassen, way south of Mount Shasta, blew 100 years ago. And here's our Shasta that we pass all the time as we go up to watch plays at Oregon. And we stay in the shadow of Mount Shasta and McCloud. We discovered a long time ago, we were looking for a place to overnight, and I said, let's find a quiet place. So 8 miles off of Highway 5 is McCloud. It's on the McCloud River. It's an old lumber town. And it's interesting in and of itself. But we stayed in a bed and breakfast that was eventually taken over by a Japanese proprietor. Why? Because McLeod has been giving a lot of Japanese tourists who want a quiet approach to Mount Shasta, because Mount Shasta to them looks a lot like Mount Fuji. And so this inn in McLeod, every time we go, we encounter Japanese tourists. And a couple of times ago, one of them performed a tea ceremony for his son and his daughter-in-law, and invited us. It was a nice experience. And the proprietor knows the great hikes to take on Mount Shasta, and gave us all the secrets she tells her Japanese clients. And I'll just mention to our loyal core, Panther Meadows. The next time you go up to by Mount Shasta, go to Panther Meadows. Okay, back to the Sierras. We finished with the Cascades. We finished with Juan de Fuca, and I am seeing that I'm getting a little bit low on time. I'll go a few more minutes since we got a later start, see if I find another natural stopping point. So in summary, this part of California was the original California, to the right of the western edge of the North American plate. So you can see a real skinny version of California. And then you get the Great Valley, and then you get the zone of the San Francisco subduction zone. So all this is new territory. We do see that although it's covered by scrapings off of the bottom of the Pacific ocean plate, that the North American plate does continue to dive down. It's underneath and is part of parts of the coastal range, but not on the surface. But it's providing the foundation for the scrapings. And this is the results of what we see from subduction, the granite, hiking in the Sierras, Yosemite being a great example. We'll see later on, we're going to do water, and we're going to do air. So it's earth, water, and air that is molded the place where we live. And we know that when water freezes, it turns to ice, and that's going to play a role in the way California was molded. And the glaciers carved out any loose granite in Yosemite. But we know where the granite came from. Before it was granite, it was the granitic magma that had gold in it. And so we have the distinct areas of California. We've already talked about these three. Aiko asked about the basin and ridge areas. We have the Mojave Desert. We're going to learn next time that the default for land 30 degrees latitude to 40 degrees latitude, the default is desert. And I'll explain why next week. So when we have dry summers, that's our default. And we'll learn how water and air create a winter and spring that makes this a pleasant place to live. Next week, we'll talk about the creation of the transverse ranges, which are here, an interesting story. We know it as we cross it when we cross the Grapevine into the Santa Monica Mountains, Shigeko. And we'll learn about that next week. The peninsular ranges are a continuation of the coastal ranges. And that's our quick top tour of the types of processes that have created. But we can now look at the areas on the map. And let's just start with the Sierras, because they were created from subduction, and the Great Valley. And let's head north to the dry area, the Modoc Plateau, and the Cascade Range with Lawson and Shasta. A coastal range, the Klamath Mountains, kind of a combination of coastal and subduction. And then our own coast now, we're south of Juan de Fuca, so we're dealing with basically the chaotic scrapings that Rawls described. Next week, the transverse ranges will be the star of the show. And then we wind up with the default again, the Mojave and the Basin range. So then basically divided into those 4 categories. Maybe just to finish with the San Andreas, here we go. We see it heading, the Pacific heading north, the North American plate easing south and creating the earthquakes. And here's the San Andreas fault described in more detail than we need. But we've experienced it back in 1989 with the Loma Prieta. But this is the San Andreas Fault in its most visible form on a plain near San Luis Obispo, the Carrizo Plain. And this is where the story of the transverse mountains, Grapevine on the north, the Santa Monica Mountains on the south. That's where we'll start next week in suspension. How did the transverse mountains get where they are? That mystery will be explained. Okay, any questions?
This is Carol. This is fantastic. I've never really had a chance to really study this at all. This is such exciting stuff to learn. Thank you.
Yeah, well, believe me, I learned a lot, and it was just following the questions I've assembled over the years and going as deep as I can. So I'm glad you enjoyed it.
It's great, and the slides are fabulous, and the pictures are great.
Thank you. I watched a lot of YouTube videos, and I read a few articles and books, and yeah, you know, I like those images. That's what makes things come alive for me. And so geology is so dry if you don't have it. So you throw in images and you throw in Steinbeck and you throw in a historian that takes some liberties, and there you got a story.
I have one question. If Los Angeles is going up to San Francisco, where are you going?
We're drifting south. The Pacific plate is the most dominant plate, and it goes wherever it wants to. So it's going, and the relative motion is mostly the movement to the northwest of the Pacific plate. But relatively, we're drifting south. Absolutely. Are we moving much on our own, or is it just relative to the north movement of the Pacific plate? And I don't know exactly the answer to that, but I'll be on the lookout. We are headed south a bit.
Oh, thank you.
Yeah.
I gotta go, so I'm gonna go.
All right.
Thank you.
Thank you.
It was really interesting.
So this is Carol again. John, this is probably a remedial question, but
Should I stop taping?
oh yeah, you could stop.